All right, so this is exploration 6.2.1, and we are going to talk about a position-time relationship. And we're going to think about this relating to a ship and its position relative to a port. Okay, so at 1 p.m., a ship is 10 miles due east of port. So that's where it is at 1 p.m. And at 2 p.m., it is sailed to a point that is 20 miles east and 50 miles north of its 1 o'clock position. Assume that the ship continues to sail in this manner as it did from 1 to 2. So it's going to continue with that same 20 miles east and 50 miles north every hour. All right, so we're going to draw a picture or a diagram to represent this voyage. Then we're going to place on our drawing the position of the ship at 3 p.m. and at 5 p.m. We'll determine how far north of the port the ship will be at 4 p.m. and how far east it will be as well. And then we're going to write a function that would give the ship's position at any given time. Okay, so let's just draw a little diagram of what's going on. So just to be clear, we're going to think of the port as our origin. So that's the port. And if we're looking at this, at 1 p.m., the ship is 10 miles east or just 10 miles east of port. So we'll make every little grid on here be 10. Okay, so the ship starts right here. And then that's at 1 p.m. So I'm going to go ahead and make a little indication of that. That's at 1 p.m. And then at 2 p.m., it's gone 20 miles east and 50 miles north. So that's, if each grid line is 10 miles, 20 miles east and then 50 miles north would put us here. And that would be at 2 p.m. All right, so we can kind of see what's going on. We know what's happening at 1 p.m. We know what's happening at 2 p.m. And we're told to replicate this pattern, that they're going to continue traveling in the same way as we go along. So at 3 o'clock, we can figure out where we would be. We would again be 20 miles east and 50 miles north. That would be at 3 p.m. And then we've got at 4 p.m., same thing, 1, 2, 3, 4, 5. And then at 5 p.m., sorry, let me put that on there. We got 4 p.m. And then at 5 p.m., 1, 2, 3, 4, 5. All right, so when we look at this, we can see there's movement here because we really have a couple things going on. We have a east-west position, a north-south position, and we have time. So we've got 3 variables involved. And so to show this movement, we're going to draw those arrows to indicate the movement from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and so on. So we've got the picture drawn. We've got our position at 3 o'clock and at 5 o'clock. And then how far north from the port will the ship be at 4 p.m.? So let's go ahead and look at 4 p.m. right here. And we just have to figure out what that value is. So take a second and you can either use this picture or just some math to figure out what our x value, or sorry, our east-west and our north-south position would be. All right, so if it was kind of a pain to count those squares or those grid lines, something that can be kind of helpful is to make a chart. So we have our time. And then what we have is we have x of t. And then we have y of t. So let's just start with this. We'll say 1 p.m. And then we are 10 miles east and 0 miles north of port. Then at 2 p.m., we've gone 20 more miles east, so that's 30 now. And then 50 miles north of our prior north-south position. So we can fill out the rest of this table. At 3 p.m., we would have gone 20 more miles to the east, so now we're at 50 miles east, and then 50 miles north of where we were before, so from 50 to 100. At 4 p.m., we'd be at 70 miles east and 150 miles north. And then at 5 p.m., we'd be 90 miles north and 90 miles east and 200 miles north. So this table can kind of help us see what's going on here. But the question was, what would our position be? How far north would we be? we would be 150 miles north, and then we would be 70 miles east. All right, so what we're going to do here is we are going to write an equation to help understand this. And so to write an equation when we have three variables, we're really going to have to write what's called a parametric equation. We're going to have to write this equation in two pieces. We need one to represent x of t and one to represent y of t. So we're going to say x of t equals, and then y of t equals. And this is going to help us know at any given time what is our position east of the port and what is our position north of the port. X is going to represent the east measurement and y is going to represent the north. So one of the things that you might want to do is take those t values, the times, and it's got 1 p.m., 2 p.m., 3 p.m., and so on. What can be helpful is to establish what time represents. So in this case, I'm going to say time equals 0 represents 1 p.m. Okay, so if that's the case, then this would be 0, this would be 1, 2, 3, and 4. You could have had t equals 0 represent noon, but that would change the way our equations look. And so let's talk about what we're going to do to write these equations and why they would look a little bit different. So if time equals 0 represents 1 p.m., then plugging in 0 to my x of t should yield 10 here, and plugging in 0 to my y of t function should get me 0. And so when we look at these patterns, our time is in increments that are constant, so plus 1, plus 1, plus 1. When I look at x of t, I see from 10 to 30, 30 to 50, 50 to 70. You should recognize that pattern. We've got a sum. So this is a linear. So this is kind of a callback to our functions unit. And so we're going to write this equation. And since the common difference is 20, we know that we're going to have 20t. Now, right now, if I were to just take that equation and plug in 0, I would get 0. So what this really means is we have to add 10 to this to make this work. So when I plug in 0, I get 10. When I plug in 1, 20 times 1 plus 10 is 30. So that works. Then for the next one, same thing. Our time is still sum, right? Plus 1, plus 1, plus 1. And then our y values are plus 50, plus 50, plus 50. So we're going to have a slope of 50, 50t. And when I plug in 0 for time, I indeed get 0 for my y value. If I plug in 1, I get 50. So that equation is good to go. Now just know, if you had chosen to represent t equals 0 as noon, our equations would be different here. Okay, and so what we're looking at now, the way we've written this equation, like I said, is a parametric equation, and the parameter, or the input, is time. And so that is what the x value and the y value depend on. They both depend on time, and they have different components, right? So in this one, x was the east position, and y was the north position, depending on what time we were looking at. And that is 6.2.1.